Yesterday we talked about how to name and write formulas for ionic compounds. So remember, ionic is going to be a metal bonded to a nonmetal, or anytime you have any of the polyatomic ions within the compound, it's always going to be ionic as well. There's a completely different way to name molecular compounds, which is the same thing as saying covalent. So now we're talking about covalent bonds, and remember this is all nonmetals. So first let's just review a covalent compound. This is where you're sharing electrons instead of transferring them. These molecules can exist independently, and the reason that's important is because it means you do not simplify the ratio. This is not a ratio of ions, this is an actual unit. They're covalently bonded, and the way you know it's molecular is that it's going to be all nonmetals. So metal to nonmetal is ionic, all nonmetals is covalent. So what I'm about to show you now, you can only do if it's all nonmetals, meaning everything to the right of the staircase on the periodic table. So what you're going to do for these are use prefixes to show me how many atoms you have. And it's actually a much simpler method from what you were doing with ionic. These are the prefixes. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. And you do need to memorize these, so put a star by this box and write the words memorize to remind yourself to memorize these 10. Most of them you already know. The number 4, tetra, some people miss that with quatra, so make sure you get that right. And then 6 and 7 can be a little confusing, but the rest of them are all pretty similar to things you've seen before. There's one exception for this, and that is that you do not use mono for the first element, and I'll show you what I mean by that in just a minute. You can use mono for the second element, and you can use any of the other prefixes for the first element. The only exception is not mono on the first element. That's it. And to show that it's a compound, you're still going to change the ending to IDE, just like you did for ionic. So let's look at a few examples. The first one, you have 1 carbon, but you don't use mono for the first elements. You're just going to write carbon. You also have 1 oxygen, but you can use mono for the second one, so you're going to say monooxide, but since there's 2 O's there, it gets a little confusing, so they just drop 1 O. So it becomes carbon monoxide. For the second one, you have 1 carbon, and again, you don't use mono for the first one, so just write carbon. The second one, you now have 2 oxygens, so instead of mono, you're going to use di and still change the ending to IDE, and that's why we call it carbon dioxide. For the next one, we have 2 P's, so you're going to say diphosphorus, and then you have 5 oxygens, and the prefix for 5 is penta, so you're going to say pentaoxide, but again, it's kind of hard to say the 2 vowels together, so notice that you can drop the A from penta and just say pentoxide. If you keep the A in there, I'm not going to count off. It's not that big of a deal. It's just easier to say if you drop one of the vowels. For the next one, 4 is tetra, so tetraphosphorus, and 10 is deca. So tetraphosphorus decoxide, and again, you can drop that A. Notice that these are not simplified. So for ionic, it's a ratio, so you're going to simplify the numbers. You do not do that for covalent compounds. And the last one is dinitrogen. And then since you have 1 oxygen, it's just monooxide, but again, you can drop the O, so it becomes dinitrogen monoxide. To go backwards with these, the prefixes will tell you what subscripts to write. So whatever prefix you see, that's literally the number that you're going to write. You don't do charges, you don't crisscross, you don't do Roman numerals, that's all for ionic, and this is not ionic. So don't forget, if there's no prefix for the first element, it's going to be mono. So here's some examples. It says dinitrogen. The di means 2, nitrogen means N. So you're going to put N2. And mono means 1, so you just have 1 oxygen. So it becomes N2O. Notice I didn't cross charges or do any of that stuff. You just, whatever the prefix is, you write that number. For the next one, you have sulfur, and there's no prefix, which means it's 1. So just 1 sulfur. Tri means 3, so 3 oxygens. You may recognize that this looks similar to something you've seen before. So SO3 looks like it could be sulfite. The reason it's not is because it has no charge on it. So sulfite is a polyatomic ion, and ion is the key word there. So to be sulfite, it would either have the charge written on it, or it would be stuck to a metal, and that's how it sticks to the metal, is because of the charge. But if you just see SO3 all by itself without any charge or any metal or anything, it's just sulfur trioxide. The next one, di, is 2, and penta is 5. So you have 2 nitrogens and 5 oxygens. Next one, there's no prefix, so 1 nitrogen. Tri means 3, so 3 hydrogens. And the last one, penta is 5, deca is 10. So you have 5 P's and 10 oxygens. And again, notice that I did not simplify this ratio. This is not ionic. So if it's covalent and you see prefixes, I need to see whatever number that prefix means. Don't simplify it. And the hardest part for this is just figuring out which system of naming to use. So the problem with molecular is that people love to use those prefixes, the mono, di, tri, and they'll start to use those to name ionic compounds, and that's going to be wrong. So before you name a compound, you need to look at that first element and see if it's a metal or a nonmetal. If it's a metal, it means you've got an ionic compound. If it's a nonmetal, it means it's covalent. Because for both of them, the second element will be a nonmetal. So you don't really even have to look at the second one. Just look at that first one. If it's a metal, or if you see a polyatomic ion, it's going to be ionic. If it's covalent, meaning all nonmetals, that's the only time you can use those prefixes. Make sure you memorize those for the quiz, and make sure you have the polyatomic ions memorized as well. And that's all for today.